Welcome to this video. We are going to learn a problem about gravitational field strength applied at the surface of two planets. A very brief recap: when you have a big planet with a mass big M, if you consider a point right here on the surface, the gravitational field strength G at this location is equal to this formula. M is the mass of the planet, and r is the distance from the planet's center to the location you are considering. This is r. And oh hey, in this case, r happens to be the radius of the planet. Alright. We have to calculate, well, let's read the problem. We haven't read the problem yet. The weight of a 2 kilogram object is 5 newtons when at the surface of planet X. The radius of planet X is a third the radius of planet Earth. What's the best estimate for the ratio mass of planet X divided by mass of Earth? Mass of X, mass of Earth. We have two planets, two surfaces, and two different field strengths. We have to use the equation twice. Once with the mass of X, and once with the mass of Earth. So let's write this equation twice. Once for X, once for Earth. Here it is for X. The field strength at the surface of planet X is equal to the constant G times the mass of X over X's radius squared, which is bigger, right? Planet X is bigger than Earth. And the field strength on Earth at the surface is equal to big G times the Earth's mass over the Earth's radius squared. Now we have to take the ratio of mx divided by m_earth. But you can't take that ratio if you don't know what each one is equal to. So let's isolate mx and isolate m_earth, and then we'll divide. When we isolate mx, this isn't too bad, whoops. We'll have mx left over on the right side. On the left side, we're going to have a fraction. There's already gx in the numerator. Now, to isolate mx, we have to get rid of rx squared. We do that by multiplying both sides by rx squared. So there's a multiplying by rx squared, which puts it in the numerator on the left. And we also have to get rid of the g, so we divide both sides by g, which puts it into the denominator on the left side. Likewise, when we isolate m_earth, we have a fraction, and there's already g, the gravitational field strength of Earth, in the numerator. We're going to have to get rid of r_earth squared, and because it's in the denominator, we multiply both sides. And when we multiply on the left, we get r_earth squared in the numerator. Now we'll also have to divide both sides by g to get rid of that, and here's our expression. So now let's take this divided by this. On the top here, I'm going to rewrite this whole thing, because that's what mx equals in the numerator. So I rewrite that. I've got gx times rx squared over big G. And then in the denominator, right here for m_earth, I'm going to rewrite this whole thing, which is what m_earth equals. So I have to rewrite the whole thing in the denominator where m_earth is over G. And you can see that the big G will cancel out. One way to see that they cancel is multiply the numerator and denominator both by big G. That's legal because big G over big G is 1, so you're really just multiplying by 1. On the top, you have big G times 1 over big G, and that's 1. In the denominator, you have big G times 1 over big G, and that's 1. So there's a few different ways to see that, in essence, the big G's will cancel. We know already the gravitational field strength of Earth. It's 10. What about the gravitational field strength on planet X? They gave us the mass of the object and the weight when it's on planet X at the surface. There's an old equation that we've learned that says the force of gravity, is from a while back, is the mass times the gravitational strength at the surface. But the force of gravity is really just another term for the weight. the object's weight. So if you're looking at the weight on planet X, you have to use the gravitational field strength of planet X at the surface. We know the weight on planet X, it's 5. We know the mass of the object, which is the same on every planet, it's 2. So we can solve for gx. We can solve for this. And then we'll know 2 out of the 4 things that we need. Okay, so let's solve. The weight on planet X is 5 newtons. The mass on every planet, how many protons, electrons, how much stuff is there? It's 2. And then if you solve for gx, by dividing by 2, you see it's 5 halves. So now we know gx, which is 5 halves. We know g-earth, which is 10. And we're really close to solving for this ratio. The last thing we're going to need is we're going to need to replace rx. Look at this. The radius of x is 1/3 the radius of Earth. If you write that in an equation, you do radius of x is 1/3 of, or multiplied by, the radius of Earth. So right here for rx squared, I'm going to replace rx squared. I'm going to get rid of the big G's here to make it easier. I'm going to replace rx squared. I got rid of it. And what am I going to put in? You know the answer. I'm going to put in not rx, but 1/3 r Earth. 1/3 r Earth. I distribute the squared to all of the factors in the parentheses. This becomes 1/9. This becomes r Earth squared. And what do we have now? We have, let me make this look more like a G, not a 9. We have 1/9, and we have r Earth squared. And voila, almost like magic, the r Earth squareds cancel out. So you plug in for gx. What's gx equal to? It's 5 halves. You plug in, you've got your 1/9 right there, and then we're dividing by 10, right? We're dividing by g-earth. But when you divide by 10, that's no different than multiplying by the reciprocal. Dividing by 10 is just like multiplying by the reciprocal of 10. And so what do we have? Well, the 5 and the 10 reduce. And when you put this all together, you get the ratio is equal to 1/2 times 1/9 is 1/18, and then another half is 1/36. And that is the answer. So let's briefly recap. We have a planet X with some mass and some radius. We also have a planet Earth, which is a little smaller, lower mass, and a smaller radius. We're essentially comparing the field strength at the surface of X, Gx, to the field strength G at the surface here of Earth, E. So we write down the equation for Gx, and we write down the equation for G-Earth. We're going to compare mx to m-Earth by taking the ratio, dividing. When we divide, we know gravitational field strength on Earth is 10. We don't know the gravitational field strength on planet X's surface, so we use the weight equation to find the gravitational field strength Gx. And then finally, we use the fact that the radius of X is 1/3 the radius of Earth. And we see now, my picture is wrong, isn't it? X is a smaller planet in size. It should be 1/3 the radius of Earth. And when we take the ratio of mx divided by me, we can get rid of gx, replace it with a number using this relationship. We can get rid of rx using this relationship. And as a result, everything cancels out except for the value. So that's how we solve.